Welcome back to our Python Quickstart tutorial series. Today's topic is object-oriented programming in Python. These topics include the definition of classes, the concept of inheritance, and operator overloading. Welcome back to part 2 of our object-oriented programming with Python session. In our previous video, we learned how to define a class. We learned that a class can have member variables and the class can have methods to work with those variables. That may have seemed as a bit of an overkill, but it's data separation. But there are more benefits to that concept. Let's go back to our example. We introduced pet as a class. Now, I want to go a little bit more specific. I want to be able to distinguish between a dog and a cat. What do they have in common? They're both pets. They both have a name. If I say, print yourself, it says, hey, I'm a dog with that name, I'm a cat with that name. That should work fairly similar, but the dog shall bark and the cat shall meow. So if I go non-object oriented, I said, oh, I have a pet. Let's copy pet, rename it to cat, modify it. Let's copy pet, rename it to dog, modify it. That's how we typically do this, and that's what's biting us. Because what if we figure out my pet class had a bug? So now I need to fix it in pet, and since cat and dog are copies, I need to fix the bugs there because I copied the bug there. Imagine that's going to be a big program. There are always bugs. You always have to fix things. And now you start fixing this in 2, 3, 5 copies of the same thing. That means somewhere you forget about it and the bug is getting a different bug or a bigger bug. There is a trick, and that's called inheritance. Inheritance in object-oriented programming is the idea that you have a class that possibly does 80% of what you want. So why not just say, I have a parent class that knows how to do it. I don't need to do anything. And your new class, you only need to change what's different. So let's look at this. What's different? A dog is a pet. It has to remember a name. It should be able to print its name. So it's the underliner in it will be the same. The underliner string will be the same. The represent is most likely also the same or very similar, but it will make a different sound. And the way how we do this is we say, let's create a new class dog. But remember, we had the keyword object here. Object is actually the master class defined in Python. Now, the dog, we say, no, our parent class, that's what should be here, is not the very generic master class. Our parent class is a pet. The dog is a pet. Everything a pet can do, the dog can do. And that's all it is. If I stop here, dog would be a perfect copy of pet. But the sound, it should say, I'm barking. And what I do is, I want to go quickly up here where we started. We looked at the pet. That was my sound function. I want this to be different, while those shall be the same. So the only thing that I need to change is the sound function. And all I have to do is define the sound function here. So I copy briefly. That was the old sound function. All I did was I replaced this by that. You see that these are the same things. We call this overwriting or overloading. I create a sound function that works sound self and says, I'm barking. I do a similar thing for the cat. where the cat is a pet, has a name, but the sound function shall be meowing. I did not define the constructor, the string, or the represent function. So if I do this, I just execute it. I created 2 more classes, but these classes are now child classes from pet, or pet is the parent class for that. So how do we use them? Let's create here my little family. I have my dog. One guy is Bash, an Australian Shepherd. Then there's my cat, Maggie. And there is the Husky mix, Kelly. And I simply remember them with the variable my dog, my cat, my other dog. Okay, let's create this. So what did we create? We created here instances of dog, cat, and another instance of dog. How does that work? Creating an instance, calling the underliner init function. So looking at this command, it's looking for dog dot underliner underliner init underliner underliner and wants it to give it the string bash. We look in the dog class. Python looks here and says, where is my init? And it says, oh, hello dog, I have no init. Let's ask my parents, maybe they know. So it says, I couldn't find it. The next step is it goes pet dot underliner underliner init. Pet looks up underliner init and says, oh yeah, I know what to do, and creates my dog.name is bash. Cat works similar. It looks into cat for underliner underliner init, doesn't find it, looks for the parent class. If the parent class has it, it uses that one. And what if the parent class doesn't have it? Then this one has a parent class and asks its own parent. What if we never defined it? Then it falls back to the keyword object. Object is that generic base class that implements everything, and typically what it does, it implements an error message. So if you fall back to that original method, it pretty much holds the error message telling you this thing has not been implemented. Let's see how that works. If I do print, hey, that is calling the string method of dog, which doesn't exist, so it's calling the string method of pet. Let's try a similar thing and look at the represent function that creates the constructor. And I've written my represent function in the pet class to not write pet, but to ask for the name of the class. So that's why it actually gives the correct class type, even in the child classes. But the thing is getting interesting when we get into the sound. Let's look at the sound. Now, I use the method sound in all objects that can do a name. Bash is barking, Maggie is meowing, Kelly is barking. How did that work? It looked at my dog, it figures out my type is my dog was a dog class object. So it's looking for dog.sound. It looks, finds dog.sound and executes this. That means that code that we've written here is hiding pet.sound. And that's why we call it overloading the original base class method. We can use methods with the same name, then we are hiding the methods from the original class, or we can add new functionality. That's the idea. So what we've done here was a very straightforward concept of modifying things. And just to make things a little more interesting, to show that that's possible, I could make here a class fish that is also a pet. Okay, let's do this. We should always have something describing string from animal represent and sound. Now we have a fish class. And I don't know what we call a fish. I want to show here that we could print my fish. It works because we had that defined. If I add to this, brings the represent function, it knows it's a fish, even though we fall back to the pet class. So you see, we actually did not overload anything. That's a nice little detail. And if I add my fish, then Willy is silent. And that comes from the logic myfish.sound, figures out fish. My fish is a fish object. The fish object is looking for sound, doesn't find sound. It asks pet and pet for sound. The pet sound was silent. So inheritance allows us to simplify code development. I want to close that section with a little discussion about how do I design that. Very often, I don't start with the parent class and then work my way down. I start with implementing something or designing a class to represent an object. Let's think we do a find element calculation. I need to build a node. So I start building a class node that holds a position, maybe a displacement, and so forth. Later on, my find element code now needs a little bit more graphic objects for plotting. So I will have something to make a point. A point may be a node, may not be a node. So I start designing a new class point. That point may have an ID, may have an X and Y position, doesn't have displacements. But now I start showing for printing, etc. They are similar. They share some variables. They share some functionality. And at that point, I go in there and say, oh, maybe instead of developing two very similar things, I should identify what do they have in common. And that's going to be my master point class. That master point class will define the variables and methods that my find element node and my plot point have in common. And then the plot point inherits from my master point class, and my find element node class inherits from my master point class. And all I have to do is code with my find element node the displacement functionality to it, or something like this. And the plotting may be a color code or whatever. The nice thing, if I figure now I want to go from 2D to 3D, things change. I just change this in my master point class, and all of a sudden, my find element node is 3D and my plot point is 3D. So the idea is always when things get complex, start looking, what do things have in common? And instead of making copies of code or duplicating code, you say, let's create a parent class, because then you have only one instance of that code. You have one central place where you can edit it. If you fix a bug, the bug is automatically fixed in all the classes that derive from that master class.